Hello and welcome to the series Computer Vision for the Real World. In this series, we're going to build the world's smartest toaster. In this video, we're going to be looking at using the basics of computer vision to do this task. What we'll cover off on is what is computer vision and what is the design process. We're going to be looking at the classification task ahead of detecting cooked toast. So, what is computer vision and how are we going to use it? We are going to build a sense and react system. This means our design needs to sense how cooked the toast is and then react by popping it. We have chosen computer vision to act as our sense. As a starting point, the task we are trying to solve is how to detect the state of the toast inside the toaster, looking at uncooked, cooked, and overcooked. If this is a sliding scale between 0 to 255 of how cooked the toast is, then we can break down this scale into 3 regions. Uncooked will take up a portion from the start till some point. Then the cooked state will exist till another point, and finally overcooked will be from then onwards. We will not know these exact points, or exactly within the cooked state where perfect will be. But now, this system is what we are trying to create. Looking deeper into that sense system, computer vision is broken down into 6 sections. The outcome we want is for the toaster to pop when the toast is cooked. A descriptor is something that describes what we are looking for. So in this case, what describes what state the toast is in? The descriptor should be able to binarize the entire image into which state we are looking for. When we segment the image, we now need to know which regions of the toast fit these classifications. Each pixel should be able to be classified as either uncooked, cooked, or burnt. This is a binarization of each state for each pixel. Also, there may be some post-processing in order to reduce some noise. Some examples might be erode, dilate, creating contours, and lastly, describing shape characteristics. The features we are going to use in order to analyze each pixel to detect if it is in the cooked, uncooked, or burnt state. In this example, we are going to use color. At each point, each pixel, we should be able to see how close the states are between cooked, uncooked, and overcooked. Since we will now receive an image from the Raspberry Pi camera, we now need to tie the raw data from the camera to match the feature extraction as best as we can. To do this, we use pre-processing. As a simple example, this will be selecting a region from the image to be analyzed that we know is toast. We may apply blurring to reduce noise, and convert the color space to LAB. The process discussed can be applied many and multiple times to keep finding more information. For example, the first iteration, we might want to detect where the toast is located in the frame, since they may move. The second iteration is just the toast pixels to determine which cooked state they are in. The third state is to only analyze toast in the cooked state and have any region where bread has formed a face. The fourth iteration may then take those face regions in the toast and detect which ones most represent a great leader. And from there, this will trigger the toaster to pop the toast. Each of these iterations follow the 6 steps and need to be tested and validated independently. If you have any questions or comments on how you want this series to look or feel free to leave a comment below. If you want a deeper understanding of what we are trying to achieve, then there'll be a link to the video that will go over that. The next video will be on the physical setup of the toaster. If you've learnt something from this video, then subscribe and follow along with the series. Thank you for watching.